Let's consider our dice roll where Z is a discrete random variable with state space omega. And omega takes the values 1, 2, 3, 4, 5, 6. The dice is fair, suggesting that the probability of Z taking a value Z in this state space omega is equal to 1 divided by 6. Complete the following two tasks. Number 1, calculate the conditional expected value of Z given that Z is larger than 3. Number 2, determine the expected value of the expected conditional value of Z given that Z is larger than 3. So that is an expected value of a conditional expected value. Have fun, just pause the video, give it a try, and then continue watching the solution. Okay, let's get into this, starting with the conditional expected value given that Z is larger than 3. Now the condition implies that we only focus on the subset 4, 5, and 6. Each state is equally likely, hence we obtain the following. 1/3, 4 plus 5 plus 6, and that should be 5. Now taking the expected value of the conditional expected value implies that we consider the expected value of Z given that Z is larger than 3. We already have it. And we also have to consider the expected value of Z given that Z is less or equal to 3. And both have probability in line with our discussion, so they're equally likely. The expected value of Z given Z larger than 3 is equal to 1/2 expected value of Z given Z less equal to 3 plus 1/2 the expected value of Z larger than 3. And that simply follows from our definitions of how to calculate expected values. So we already know this part here. We consider in this case only the outcomes 1, 2, 3 were all equally likely. So we would obtain 1 plus 2 plus 3, and that's times 1/3 plus 5/2. So that should give us 2 here, and that should give us 1 the first bit, so 7/2, 3.5. Now basically we illustrate, if you go back to our previous calculation, that this is nothing else but the expected value of Z. Now this actually follows from the law of total expectations. So this is a nice way to illustrate that law. It's not, of course, a formal proof, but you see it in action, which is sometimes useful to understand a concept. I see you in the next one.